Right.
Sweet. Thanks for coming along, everybody. I see group is forming here. Some new names to the group. It's exciting. We did move a week after our normal, so apologize for the slight shakeup in calendar, but I think we should have a good group joining up here. Try to get back on track for next time. Got a couple of ideas for our next speaker, but if folks have ideas for other people you'd like to hear from, we're kind of turning our theme toward kind of fundamentals of interoperability and looking at basics that we all need to remember and apply in our kind of new cloud technology reality. So if you have ideas of people who are really good on kind of fundamentals and basics, but are forward looking in terms of technology, I'm looking for ideas of speakers. So bring up the rest of the calendar here soon for the spring and summer. So stay tuned. This is great. We've got a bunch more people joining up. I'll go ahead and roll into introductions. Looks like we've got quorum, so I'll find chat again. So if folks could go to that Google Doc and sign in and help take minutes or jot any major takeaways down, that'd be much appreciated. I copy the minutes and any kind of major takeaways into the wiki to accompany the recording of these talks to hopefully drive a little bit more traffic and a little awareness of what we talked about beyond the recording. So thanks for any contributions you can make in there, and we'll go ahead and jump in. So thanks for coming, everybody. This is the ESIP and USGS Community for Data Integration, Information Technology, and Interoperability monthly seminar. This month, I'm really excited to hear from Jed Sundwall, who is Executive Director, CEO,
Executive Director, yeah.
Right on, of Radiant Earth, and a really thoughtful writer on topics near and dear to my heart. I ran across some of the Radiant Earth content on Medium and got led over to Jed's blog and have found his insights really powerful and insightful. So really excited to hear what Jed has for us today, and I'll turn it over to you to kind of introduce yourself and take it from there.
Thank you, Dave. That's very flattering, and I'm glad to be here. And I think I should warn everybody. I pulled up the email you sent back in October, so this has been a long time coming. But you did say that the seminar series was on a rant and rave topic, so I've come prepared to rant and rave a little bit. I hope that's still okay.
Please do. That was where we were last year, and we're starting to shift our focus toward fundamentals of interoperability, but it's a shift. And I hope to keep that rant and rave energy going as we go.
Okay.
So all right.
Good. And I'm sorry, I'm here with my cat too. I normally don't do calls I'm just like in a lounge chair, but I tweaked my knee yesterday, so just explaining my weird setup here. So yeah, I'm Executive Director of Radiant Earth. What I have up here is our slide with our mission on it, which is to incubate data-driven initiatives, services, and 21st century institutions needed to foster shared understanding of our world. And that last part is the part that I'm sort of most passionate about, is that as we face global challenges, it's really important for us as a species to understand collectively what's happening on the planet. And so I'm going to talk about, my thoughts on open data and why sharing data is very important, but why we need to be, I think, a bit more sophisticated about how we go about it. But all with an eye towards improving human cooperation at global scale. That's the task ahead of us. So let me go ahead and explain, so what are these initiatives and services? Right now, for the most part, we have two flagship initiatives. One is called the Cloud Native Geospatial Foundation. We've been very involved with the ESIP cloud cluster. So we're big fans. We love ESIP and happy to contribute wherever we can. But our job at the Cloud Native Geospatial Foundation is basically to figure out how to encourage people to adopt more efficient ways of working with data on the internet. So, and I'm going to talk about this quite a bit in this session, like what we mean when we say cloud native and why this matters. But that's basically like an education and community engagement function, is that we have this sort of umbrella organization that we do this work under to get people to work on cloud native approaches and educate more people to benefit from them. Source Cooperative is more of a service. It's kind of like a SaaS application, kind of like an infrastructure as a service thing. What it is basically a way for people to publish data in a cloud object store without actually having to touch a cloud object store directly or have to manage it themselves. And I'm going to talk a lot about Source as well. But the long story short is that our thesis is that you can basically share any kind of information you want by putting files on the internet. I deliberately say this very simplistically, but it's true. Like the gesture that you need to make is just to put binaries up on the internet and available over HTTP. That part is kind of simple and easy to explain. The hard part is figuring out, well, what format should those files be and what kind of metadata should you provide? How do you assert authority? How do you provide customer support and governance and things like that? That's all the hard work. But the technical part of sharing data is really just a matter of putting files on the internet. And Source Cooperative is created to make that much easier for people to do. So let me level set in terms of like what we talk about when we're talking about cloud native. It is broadly just file formats that work well when shared over HTTP for the most part. Without getting into too many details here, and you'll see here, there's the link on this slide to guide.cloudnativegeo.org. Our friends at Development Seed produced that in collaboration with NASA Impact. And so that's a great guide that explains all of this in much more detail. But in short, it's basically there are file formats that allow you to work with them very efficiently using distributed computing infrastructure. In many cases, what that means is having little bits of metadata that you can access really quickly that will give you clues as to the larger scope of the data that you're working with. And in many instances, it also includes the ability to perform what are called range requests, where rather than having to download an entire file, you can only download part of a file if that's if it contains the data that's interesting to you. There's a lot of nuance in all of this, but what we're trying to do is help people understand that you can actually share very, very large scale, planetary scale data products on the internet and make them very performant in such a way that people can build applications on top of them that work in the browser, as well as, we're saying cloud here, but I think one thing I always have to reiterate or sort of iterate is that you don't have to use the cloud to benefit from these things. But in many cases, if you do have very large scale analysis to do, if data is hosted in the cloud, certainly you benefit from being able to scale up compute in the cloud where it is. But I would say when I talk about cloud native data, I'm speaking more broadly, sometimes in terms of web native or web friendly data as well. Now this matters because it can dramatically lower the cost and effort required by organizations who want to publish data. So historically, organizations that have shared data, oftentimes you'd set up, when we talk way back, FTP servers, where you have a server where you have a ton of data that you're making available, and your expectation is that somebody is going to come get that data and then transfer it to their own server from the FTP server, or locally or wherever they need it. what we're saying is you don't really need to do that anymore. You should be able to stream data out of a central location, just like a web server. And the good news is that cloud, the big cloud providers, they're all competing with one another, and this layer of their stack, which is called like object storage on Amazon, it's called S3. Azure has Azure Blob Storage. Google has Google Cloud Storage. These are all functionally the same things that allow you to put files on the internet. This is a commoditized layer of the stack that there's pressure in the market to make this cheaper and faster and better all the time. And so this is a really just much more efficient way for people to share data than having to maintain their own servers, or in other instances, create data portals or maintain APIs and things like that. On the data user side, they're able to benefit from just having data available for them over generic HTTP methods and open file formats. This we've shown over and over again allows people to build applications, do analysis in things like Jupyter Notebooks or R much more efficiently than if they're having to wrangle with a lot of different APIs or services or portals, and some of which may or may not have different authentication schemes and things like that. And ultimately, what this should result in is just many more applications being made available for end users at the end of the day. So another way to sort of frame the state of things right now is through this notion of pace layering, which I love. I got this from Tom McWright, if you know who he is, another guy in the geospatial world, a very, very thoughtful guy. But he introduced me to this concept. This is from Stuart Brand. And the idea that, the world that we inhabit is built upon tops of layers, fundamental layers that change at different rates of change. The world's always changing, but some things change faster than others. And so, fundamentally, there's nature, culture is develops on top of that, governance, infrastructure, commerce, and then if you have all these things and operating, on top of that, you can have wacky things like fashion, that just like who knows what's going on, but constantly changing, and it's just part of the human experience. I think this is fun to sort of think about this in terms of data infrastructure, is that you have nature, and then on top of nature you have the internet protocol. So that's like a fundamental thing that really does not seem like it's going to change anytime soon. On top of that, once again, something that's not going to change that much is HTTP. And then the way I see things playing out after that is that you have basic standards or pattern, file formats, metadata, specifications that are built on top of HTTP. If you can get that right, then if you're going to produce a sensor, if you can produce some kind of instrument that's going to produce more data, you should have an idea of what kind of existing standards you're going to put it into, right? So, I mean, a good example of this is like we've actually been working on a project funded by AWS to work on air quality data and improving access to air quality data. Air quality sensors, they don't produce very large data. They produce a lot of data, but it's not very large data. There's small readings, and they're really best suited to be shared in CSVs, right? So you don't want an air quality data sensor manufacturer to come up and be like, okay, we're going to share our data, not in CSVs, but in some like bizarre proprietary format that we make up. That's not what you want. So what you want to have is a layer of formats that are built on top of HTTP that are broadly used, and then that should free people up to not have to reinvent the wheel if they produce new sensors. And then on top of that, what I want to see is a world in which we do have kind of like wacky interfaces being developed all the time, and there's a lot of innovation in that space. I'm still getting better at sort of articulating like why this matters, but where I'm landing is that sort of historically a lot of power has been accrued by software firms that were able to make their software like sort of the de facto way of working with of working. So not to pick on Microsoft too much or anything like that, but like Word and Excel are good examples of this. For a long time, like the only way to share a document was to share a Word doc. The only way to work with a Word doc was with Microsoft Word. And so by controlling the standard and creating a lot of market power around their software, they created a network effect, whereas it's sort of like everybody was expected to be able to work with Word docs. And the only way to do that was to use Microsoft software. What's happening today is that software is getting cheaper and cheaper to create and easier to create and deploy because of the web. And that trend shows no sign of slowing down, especially with things like WebAssembly that allow you to run Python in the browser, and JavaScript just becoming, it's cool. Like you can do a lot of stuff like just in the browser. And then, I did not anticipate how ChatGPT and large language models would also change how people write software. And so it's going to be harder and harder for people to create software monopolies, I would say, around code, like around the actual applications that people use. And what's going to become more and more important is actually data, data that informs models or data that people use to work with things. And so rather than software providers kind of calling the shots in terms of what standards are developed, I think we're going to end up seeing many more sort of what I would call primitive standards that are practically useful and completely open, that are designed to work on the web, that will, that everyone will use in the future. And we're already seeing that happen. So anyway, and then, to sort of drive the point home, like this is how we see our role in the community is providing a method to make it easier for people to share data over HTTP with source cooperative, and then creating a space for us to learn together, like of the best ways to do that with the Cloud Native Geospatial Foundation. And then, if you'll let me, so the theme, I think, this talk was creating great data products. So that's a lot of preamble. So, okay, so let's assume like we've got standards, we have a place to share data. Now the question is like, well, what does a great data product even look like? So like, what is it? So this is what source cooperative looks like. We borrow a lot from GitHub. That's very obvious. I'm not shy. I'm not gonna pretend it's not happening. Like a lot of the concepts of GitHub are all here, and that we have the notion of repositories, and then users, and those can be individuals or organizations that produce repositories. And so you can see here, a repository has a title, it has a description. We allow tags, just people to select any kind of tags they want. We show people where it came from, and we show people when it was published. This is what we have right now. And then as you go through a data product, then you also, there's a README file that we encourage people to have. Again, very similar to GitHub. You just put a markdown file in your repository, and that will render on the Source Cooperative website to show people the documentation of the repository. And otherwise, you can just look at the files. And so, in fact, give me a second here. I'm trying to, okay, I meant to put a slide in here, but let me, actually, I'm going to risk it and go live here. Give me a second here. I'm going to switch over to my browser, and I'll just show you all Source Cooperative. So I'm going to stop sharing for a second. Hold on. I'm looking for the thing. Okay, the big green button is what I was looking for. So, and then, okay, so this is what a repository looks like live, right? This is one that we really like. It has a nice README file. It's well formatted, pretty robust. But I just want to show you again, like what it looks like if you browse a repository. So what this is this is a bunch of content in S3, and we're just showing it to you in the browser, and you can just click through and browse it nicely in a web browser. And this one contains a bunch of different, it contains Parquet files, GeoParquet, flat GeoBuff, and then PM tiles. Now, PM tiles is an interesting format for a few reasons. One, it's just it's a fascinating format. It stands for protomaps, protomap tiles, but it's a vector tile format that allows you to stream it. And if you'll notice here, this is about a 200 gigabyte file. Now, we have a viewer built into Source Cooperative that allows you to look at it in the browser. And so I can zoom in anywhere in the world. This is Sao Paulo, and it will render building footprints as I come in. And this is what I talked about before. This is making range requests. It's streaming data just as I need to see it as I, pan around and zoom in the browser. And it's worth pointing out here that there is no server running here. This is just my web browser making requests from S3, and I can go anywhere in the world. But what I want to emphasize here is that what we want to do with Source Cooperative is create what I call kind of like the finder or like the file browser for the planet, where you can come to this file and you can see some metadata about it. Right now, the only metadata we show is the name of the URL. But in the future, we could also show like a checksum so that you can validate the data, more information about when it was created, who created it, and things like that, if it's been modified, and things like that. So that's another one of our goals here. But back to the concept at hand of like what makes a great data product. My This is just where I'm just start sharing my own opinion. But also, which is encoded here in source, which is that there's really kind of no way ex ante to determine like this is a high quality product. Like no one knows. And also we don't want to back ourselves into a corner with any kind of particular data model. Our data model is the web, I guess, which is that like you can put a binary you can put a binary on a server and you can make it available over HTTP. Like that's it. The example that I sometimes use is like, if Warren Buffett, somebody like that a lot of people regard as a really smart oracle who has, a lot of valuable insights. If he were to say like, hey, I've got an Excel spreadsheet that I look at every day and my team updates it and we're going to put it up on the web and you can look at it, people would find that to be valuable. Like they wouldn't ask like what, like, oh, you're using Excel, they wouldn't ask about like his metadata standards or anything like that. They would go figure out like how to benefit from that. That's not to say that we shouldn't be doing work to all get on the same page to streamline how we share data with one another. I'm certainly not saying that, but all I'm saying is that the value of a data, like what makes something great, it's dependent on so many factors. And one example that I like to use is the IRS 990 tax filing data. So I know we got some nonprofit people on here. We all have to file 990s. So our financial information that we share with the IRS is public data. And the IRS was sued years ago to make that data available in a machine readable format. They used to say that like, oh, it's open, but like, just email us and we'll send you like a DVD of some PDFs. And a guy named Carl Malamud said, no, that's not okay. Like you need to give it to me in a machine readable format because I know you have it in a machine readable format. And the IRS lost this lawsuit. And at the time I was working at AWS running the open data program at AWS. And I got connected to the IRS because I'm a huge like open data nerd. I knew all about this story. I'd been following the story and I was very excited to say, yeah, like we'll host this data. And the IRS, not surprisingly to many people who've like worked for government agencies, they didn't have a lot of resources to make a great data product, and really think about how to make all the tax filing data easy for people to use. All they knew is they were like, okay, we can create some XML files and we can just sort of spit them out and figure out how to get them into S3. And that's all they did. And what we ended up with was like thousands and thousands of XML files that use different schemas that were not documented, but that had the data. And lo and behold, this was a great data product. It was awesome. People loved it. They didn't like working with it because it's such a pain. And I have here on the slide, a blog post from back then. The Aspen Institute like had to like gather a ton of people from a bunch of other different institutions to start combing through the data and sort of reverse engineering documentation for it and writing scripts to make it useful. And I share this story just to point out that again, that like there are some data products that are intrinsically valuable. Like the IRS, the 990 data is so useful to journalists, to activists, to people who support nonprofits with fundraising, blah, 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 like whatever, services to nonprofits. The data, everyone knew there was sort of gold in all those XML files, and they were willing to go through the work as a community to make it useful. And that's because the 990 data was intrinsically valuable. And so is this a great data product? Kind of. I mean, it's valuable enough that like a lot of people went out of their way to make it useful. Was it great in terms of it being formatted well? Certainly not, I would say. the one nice thing was, I mean, I'll say, like, and I'm biased here, it was on AWS, it was very easy for people to work with at scale. You know, it was just like a bunch of going back to my earlier point, it was just a bunch of files on the internet, and then people were able to work with it very efficiently. Um, so now the data set that I was showing you before, the building footprint data, it's from a group called VITA. So they're actually based in Munich. They do some very interesting work, helping improve access to data for infrastructure development in low and middle income countries and stuff like with the World Bank. And I think their data set's an example of a really great data set. It's very well documented, like I showed you. And there's this, and I love this story. So of what happened when they published it. So they published it last year in September, and so it went live at 7:17 a.m. Pacific time, and within a few hours, this guy Postholer had created a mashup of it with FEMA data, and then a few hours later, Q Sheng, who I'm sure is known to many people in this community, had written a tutorial and produced open source code to work with it. And then a few weeks later, somebody who I had never encountered before took some UN data and some Bolivian census data and was able to use it to create his own mashup. And I'm very fond of this slide because I actually made this slide for my board. Or it's actually to recruit new collaborators and board members. And I was like, oh, I should probably show people Source Cooperative. And so this was the slide that I created. And I came back, a day later to work on the deck again. And I was like, oh, like I made this slide about Source, and then nowhere in it do you see Source. Do you see the interface? And and I realized that's exactly the story that I want, is that a great data product should also be very fungible, and should be able to appear in a lot of different places in a lot of different contexts. You want a lot of flexibility to come out of a data product, I would say. So now I know we have through the hour, but I also want to leave a lot of time for questions. But I'm going to keep. I've got a few more ranting and raving. This is a bit of a pivot, which is that I also think it's really important for us to be clear-eyed about what data is actually good for and how it gets used. And so there are two things that bounce around in my head. Two ideas. One is, so there's this guy named Jeff Mulgan, and for what it's worth, Jessica Seddon was a professor of mine at UCSD many years ago, but we've stayed in touch, and she's a great thought partner to me. She introduced me to Jeff Mulgan's thinking. Jeff he's a guy in the UK. He used to run Nesta, which was the National Endowment for Science, Technology, and the Arts, I think, in the UK. But a really good thinker. But they're both collaborating on a thing called it's the Institutional Architecture Lab. And one thing that they're working on and that I'm very interested in is the fact that we don't have great global institutions that exist to enable global cooperation. So taking it all the way back to the top of like our mission of increasing shared understanding of the world, we in the US, I mean, assuming a lot of the people on this call are US based or work for federal agencies, we're really lucky to work, to live in a country and to be able to work with agencies that have enough wherewithal that they can produce global products like Landsat, like an incredible data product, and just give it away to the whole world. Europe does the same thing, and there are plenty of other countries that also make global data products available. But I would say that's really remarkable and exceptional, that happens. We obviously have big NGOs. We have things like the World Bank and the UN that do heroic work to make global data sets available. But it's very rarely their core competency is to make data available and support a global community of developers. Most government institutions and public sector institutions are not funded well to do that kind of thing. We need to figure out how to solve that. Just to share another war story from my time at AWS, but we had a big cooperative agreement with NOAA, and we started bringing on NOAA data into the cloud. We brought in the NextRad radar archive. Really, also, again, very cool data set, an amazing product that they made available to everybody. And through the ingestion process, we found out that a lot of the files were corrupt. There was some data corruption in the content. And Noah's like, okay, Amazon, fix it. And we're like, well, we're not experts in this data. Like we're not we don't really feel qualified to fix your data. We're not experts in radar data. And so we just kind of had this like back and forth going. And what we realized, like, NOAA's job is hard enough to build all this infrastructure and start producing all this data and support their own mission. The idea of then also additionally making, in this case, many terabytes of data available to the whole world and providing support for it was just not within scope. It just like wasn't realistic. And that keeps happening all over the place. I see that everywhere. And yeah, I will just say bluntly, like, we don't have institutions that are actually tasked with producing great data products and making them available for the whole world. And while Landsat is incredible, and the satellite data we have, from the Copernicus program as well, is truly incredible, there's still so much more that we need to enable cooperation on things like creating ethical supply chains and things like that, where we don't have great institutions to solve that. And then the other point here is from Jessica, where she just wrote this blog post quite recently. So I just included a link here to her blog so you can see it. But where she talks about the fact that she keeps running into imaginary decision makers, and this is a bit of magical thinking that I think is really important for us to address head on, which is that for so many years, and I think Dave, this is the blog post that you'd initially shared with us when you asked me to do this. Is I wrote this blog post called like "We Don't Talk About Open Data," where I was trying to cut through a lot of the magical thinking around open data, where people are just like, if we only had more data, like we would know what to do, and then like we would have the information and we would do the right thing. That's just not real, right? That's not how decisions get made. Humans very rarely make decisions based on data. They make decisions based on social status and incentives, fear, things like that. But the good news is we can build institutions that are steered by data. And so anyway, I highly recommend looking up Jessica's blog post and reading it. It's good. But anyway, I was very impressed with the lead of the post. So I made this meme, which memes are very useful, I think, too, in terms of like driving a point across. But what worries me, sort of what keeps me up at night, and what I'll really rant about, is the fact that like we do all this work and we fund all these talented people to produce great data products, or any kind of data, and then we're like, all right, somebody do something with it, and we end up with the government saying, oh, we got to force the commercial sector to do this, and the commercial sector is like, no, it's not our job. Like this is on you. And so, and then, of course, then the business leaders will lobby to make sure that the government does their job, but not in any way that's going to impact the corporation. And then, yeah, I would jokingly say that like both of them just kind of hope like, well, if we do a hackathon, then somebody at the hackathon will do the right thing, and then they'll start a startup, and then everything will work out. And this is just foolishness. I would say, I'm pretty confident in that, like, I hear about hackathons less and less, which I'm excited, which makes me happy. I think people are maturing their approach to thinking about like how data actually gets used in society and how it gets used to make decisions. And I'm very optimistic about that. But we still have a lot of education to do, a lot of work to do, and the challenges ahead are really big. It involves creating new kinds of institutions, and that is, I'm under no illusions that that's going to be an easy thing. So I'll leave it there. I see there's some stuff in the chat, people yelling at me. Oh, good. This Dave's sharing the links to the blogs. Okay. And yes, Dave said you can't fix GRIB data. It's more. This is not GRIB data. This is NextRad. Is there? I forget what the file format was, but we also interacted with a lot of GRIB data. We can have a discussion about cloud optimized GRIB if you want. I'm sure someone's thought about that, but
a wise man once told me that the GRIB, so the comparison between NetCDF and GRIB is that NetCDF is like a pack of cards that's well organized. Okay. And GRIB is where you just chuck the cards on the floor.
Yeah. Okay.
Anyways.
It's I love talking about like the histories of file formats. I don't remember I know I've heard interesting things about like why Grib is the way it is, but I forget them. But like the TIFF, my understanding of the TIFF is that one of its original applications was for sharing fax data. You need to share it sort of like line by line pixels to be faxed out, printed out on a fax machine. And we still use them. The tarball, that stands for tape archive. So there's all sorts of interesting legacy stuff in these formats we use.
Yeah, it's fascinating. Thank you for the talk. It's really, really good. And I wonder if you can, there's a key thing in back at the beginning of your description of what cloud native means,
Yeah.
that has to do with, um, well, can you talk a little bit about the interplay between what it means for metadata to be available upfront, to be able to do partial reads and be
Yeah.
able to parallelize reads? I guess I think
Yeah.
I don't know that everybody recognizes that that's what cloud native really fundamentally means, and that there's an architecture there that is really guides a lot of decision making about an information product that you're trying to build.
That's right. Yeah, thank you. The issue with cloud native or like web native, but yeah, what we're talking about when we talk about cloud native is that there's content that's hosted somewhere that you don't know exactly where it is, and there's not necessarily an easy way for you to find out that much about it. Because the data is hosted remotely. It's a distributed compute paradigm where there's a server somewhere where there's some stuff. So you have to know, first of all, like that there's a URL that you can go to where you're going to get like a TIFF file, right? This is very different from the way people normally in their day-to-day working with data locally interact with data. If you have a laptop or whatever, if you have like a local workstation, you have a file system that is indexed everything that's on your hard drive. And you likely have an application that you can open up that will recognize on your that is aware of the file system and that is aware of content on your local storage that it can open, right? So a lot of that work, like sort of the work about knowing sort of like where data is and what it's comprised of, is all handled by your file system. So when we're thinking about data on the web or like in a distributed environment, you don't have that benefit. And so what cloud native allows you to do, or like what a cloud native approach should allow you to do, is to say like, you'll still have to like be pointed somewhere to like a web page or like some sort of documentation to say like there is content here, and in fact that is what Source Cooperative aims to do. It's like you can go to Source Cooperative and you can say like, and you can see a bunch of data products that are hosted in this way. If you have the right metadata. So, and let's start with the example of a cloud optimized GeoTIFF, because there's a kind of straightforward story to tell here. A cloud optimized GeoTIFF contains a bit of metadata at the head of the file. So if you have a library, if you're using code that knows how to read that head, just that little first bit of the file, it can tell you, it's like, oh, yes, hi, I'm a GeoTIFF. It says hi, it's very polite. So I'm a GeoTIFF. I contain geospatial data. These are the lat long, the coordinates that I cover. And also, this is optional. I mean, well, I think Cloud Optimized GeoTIFF has to have internal tiling. You can also say, also the data that I contain, the pixels I contain, are arranged in tiles of these dimensions. So maybe, 256 pixel square tiles. With that bit of information, just so you know, like you just know enough about the file, you can then say, okay, cool, this is a file that's over this part of the Amazon. I'm interested in this part of the Amazon, and I can make now a range request to not download the entire file, but just go get those little bits that are relevant to me. That is the sort of the story of a cloud optimized, like streamable bit of content. Now, there are a lot of other formats that like you don't need to do a range request. And ZAR is a good example of this. If any of you have looked into ZAR, where just says like, no, like we're going to blow up everything and we'll have individual files for lots of chunks throughout this array and these dimensions of this array. So rather than doing a range request, you go through with a ZAR store, you get access to a catalog that tells you about itself and says, if you're looking for, this part of the array, you can go here and get it. And you're not doing a range request, you're making a specific request for just a part of that store. But the point in all of this is that you're giving people sort of a map to the content so that they can navigate it, little bits at a time. And then figuring out sort of the right size of those bits or those chunks or whatever, it's a bit of a science and an art. You want to do it in such a way that you're not forcing people to make too many requests, because if you have to make lots of requests, just the request time starts to add up. But you also don't want to do it so like, they make a few requests, but all those requests are huge. So it's a very, it gets complicated pretty quickly, trying to figure out like these right sweet spots, but that's what we do with the Cloud Native Geospatial Foundation, is argue about these things. I hope that was helpful. I don't know, like.
Yeah, no, that's exactly what I was hoping you just kind of tease apart a little bit.
The thing is, it's just so unintuitive to people who are just like, why can't I just open it in my file? It's, yeah.
Yeah, I started my career chunking that CDF to work on a traditional storage network.
Okay.
And to allow high performance threads on premise services to work. And it's been really fascinating because the same basic metrics apply of latency per read. How much time does it take to read a chunk because you're uncompressing a chunk at a time? These kinds of things still apply.
Yeah.
But the numbers on each of those metrics are very different in the cloud. So you end up with different answers for how you design these products, which anyways, and it's not intuitive. It doesn't make sense because you have to think like the computer and not the way you want to. So.
Yeah. Yeah. No, it's not intuitive. It's a great new world.
I like it. I mean, this idea that the metadata here is the map, where like you have essentially you're exposing the index to the data.
That's right.
In a way that people can then leverage it. I think that's a really important way to think about it.
Yeah. It's just it's funny. Yeah, yeah. Since I'm ranting and raving, I guess I should have license to do this. But like, one thing that I love to think about when thinking about these things is it's a short story called "The Library of Babel" by a guy named Jorge Luis Borges. He's this Argentinian writer who just wrote these crazy, mind-blowing short stories. But he describes a library that contains it's made up of all these rooms that are identical, that have shelves that are identical, that contain books that are all of the same length and have the same number of characters per row and blah, blah, blah. And same number of rows per page, same number of pages. But the library contains every possible combination of characters that could ever be printed. And so what he's described is a space that contains all information, like all possible information. And anyway, it's like a very, I don't even know if you'd call it a short story. It's more of like a thought experiment where he describes the space. Because you realize you're like, oh wow, this book contains every book that's ever been written and ever will be written, with every possible typo that could ever be in it. It contains an index of itself. And but it's so vast that people are like, oh, this is useless. Because like you pick up any book off the shelf and like most books don't contain anything that's legible at all. And but that's kind of like, anyway, I just think like that's what we're creating like with the internet, is that like you do have this kind of like, it feels like an infinite space where you can have all sorts of data, but getting an index, like knowing where to look to find things and creating an index that's the right size, that isn't overwhelming, that you can actually read, is hard. Like it's really complicated. So anyway, I highly recommend Library of Babel.
I like it. Captured that. All right, I have plenty more questions or things we could talk about, but anybody else wanna?
Aaron just left a comment. So data quality, data importance, including yeah, so that, I mean, so the question is, yeah, how do you see data quality or data importance, including data provider trustworthiness, being effectively conveyed to users? So this is something that and forgive me for, I don't want to sound like I'm shilling for source, although I'm the executive director of this organization. I shouldn't apologize, but like, this is something we're trying to work on a source, and we haven't figured out yet. right now we know everybody who's uploaded data to the platform. Like we know who's using the service while it's in beta. But when we come out of beta and we open it up for more people to come in, we see it as being very important that we know who those people are, and that we can ensure for their trustworthiness. We are, we're a nonprofit. We have different revenue model. We have different ways of accessing capital. And so one thing that I'm considering is that we should charge actually everybody for to join Source. So we at least know that people, like, we really know who they are. We know that they're banked, like they have a credit card or something like that. And we can do some extra work to like authenticate them and see when they've been authenticated. This is in contrast to a lot of other platforms that have been created on the internet where their only goal is to get as many users as possible, and you don't really care who they are, and you don't have any incentive to worry about who they are or how trustworthy they are. And I think we've seen on social media how that can create a pretty toxic information environment, and we certainly don't want a toxic information environment on Source. So a big part of that is making sure that we really understand who people are on the platform. LinkedIn, I feel like they've established some good patterns for verifying people's affiliations, and keeping their information up to date and having that be credible. So I see that as being, at least on Source, as being an important design consideration, because one thing we're trying to solve for is the fact that, like, there are a lot of organizations that it would be cool if they shared data, but they don't really have the resources to build and maintain their own data portals. Right now, if you get data from a nasa.gov URL, you're pretty confident about where it's coming from. And you have, to the extent that you trust NASA's data, like, you're going to feel good about that. But we're trying to create something where, people aren't running their own domains. So how do we verify that they are who they say they are? So not still to be solved, but a super important thing to consider. Any other questions? I'm trying to see my cat. Okay, we go.
We got another
Yeah.
in the chat here.
I'll read it here. From Rachel. I agree with you about the importance of social factors and how people make decisions. What do you think about the implications of this for metadata for open data in the cloud? Well, yeah, it's how would I draw a line between those two things? I mean, the story that I like to tell of, like, how I want data to be used in the cloud, and how, like sort of my dream for Source, like, how would I know that Source made a difference, is if it can win a lawsuit. So going back to the, this whole, I want to just end on the Spider-Man thing. Like there are a lot of we're getting good at measuring emissions from space, for example. And so and there are groups also, like, I think it's Sky Truth is what they're called. I hope that's what they're called. That like they'll track oil spills using SAR data, which is incredible. It's one thing to know what's happening on the ground. It's another thing to, like, actually make change happen based on what that's happening down there. And so how does that happen? In many instances, the way that can happen is through lawsuits, And so, I mean, a good example of this is, like, the Environmental Defense Fund is they're launching methane sat to track methane emissions. Presumably, they're going to use that data and take it to court. You can find the polluters and say, like, okay, you guys are polluting the atmosphere, and there's some sort of legal recourse they can take for that. So to answer, where does metadata come in here? The story that I daydream about is that you could go to court and say, like, look, here's the metadata. Here's the data that we're using. It's available at this URL. Here's the checksum. Here's when it was uploaded. And so to the extent that people trust Source as an arbiter of data, or really wherever the data is coming from, you can take that to the court and say, like, we have records of observations that were made at this time that show this happening. It's very clear that it's all coming from this factory, blah, blah, blah. And so that's an instance where, credible metadata, I think, could, I'm fantasizing right here. So take this with a grain of salt, but, like, that's where metadata could actually come in handy. because it would allow people to gather, to provide evidence of something happening that was, yeah, like what could be upheld in court. So that's one theoretical example. But I would say just generally, like better metadata allows people to just move more quickly and make more confident assessments and analyses of data.
So kind of on that topic,
Yeah.
something I put a lot of thought into is the relationship between really high quality baseline information that we use to basically judge other information against.
Right.
So, you have these basically reference grade, lab grade observations that are used to calibrate remote sensing or whatever
Yeah.
it is, right? That need to be tied back and related to a lot of the really big data that we use. That's essentially, some model applied to a remote sensing signal. That's one piece of it. You've got things like the base observational data that helped inform the algorithm that was used for remote sensing, right?
Right.
But there's other things, other observations that are really foundational to what we assume to be correct or what we assume to be accurate, right? And I often worry that we are kind of losing sight of those kernels of really high value information that like the insurance industry relies on that as a statement of fact. And all this other big data kind of doesn't matter compared to that one little kernel of information.
Yeah.
I guess, do you see a place that we have those hooks in these kind of big repositories of cloud data where
Yeah.
we can come back to these things that are kind of overarching or overriding in some ways because they have so much impact deeper
Yeah.
down in the stack?
Well, this kind of goes, this goes a bit back to like, again, that original post about like, we don't talk about open data, where I was just like, we should stop talking about open data. We should start talking about creating better data products. And so yeah, I think and I had a hand in this. I think like the federal open data policy, I forget what the bill was named when it finally passed, but like, I helped contribute to that, and like was very much on the side of like, yeah, like make everything open by default. And like why not? And I somewhat regret my my stance. I did, knowing what I know now, I'd be like, maybe I would have toned it down a little bit and said like, hey, now we know it's unrealistic for agencies to make everything open by default. We set people on a path of creating enterprise data inventories, which was like, all right, USGS, like figure out all the data that you have and then tell us why you're not opening all of it. It's like, well, that's kind of silly. I think we really should focus, and I think the way that you put it is really great, is sort of figure out like what are the things that have the largest impact, that are the most fundamental, and let's make sure that we're really prioritizing their production and accuracy and availability and things like that. And that requires a bit of a judgment call. But it also, those are the kind of things that you should be able to instrument and understand, like, oh, like there's this section of the economy that like is responsible for this, this much GDP that relies on access to this data. We need to treat this as one of our like crown jewels. I think taking that great data product approach and sort of having the what'll be uncomfortable for some conversation, which is that some data products are better and more valuable than others. And simply like just sort of like throwing up our hands and being like, oh, we're just opening up everything, and saying instead that you're going to focus on a few more important things. That makes a lot of, I think that we should be more thoughtful about like what are the data sets that really matter. I kind of lament that the enthusiasm for opening up data somewhat naively distracted us from that for a while. So yeah, I'm here repenting in front of everybody. I'm glad this is recorded.
I don't mean to call, I mean, I see that to be a really hard balance, and I guess I appreciate the nuance there, and yeah, I don't think you need to feel bad for saying everything should be open, because it should, right?
Yeah, well, yeah, I mean, it's not,
But
you
that's
know,
not enough.
not the
Yeah,
worst idea. Yeah, it's not
yeah,
enough. And like, I mean, the other thing I would say is that like we we also have to be careful. I mean, like something that we've thought about with source and that we're actually doing right now is instrumenting it. Like we know which data sets get used. I can speak from my experience with the open data program at AWS is that I'm not sharing any proprietary information. Some data sets were used more than others. There were some that were blockbusters. There were some that no one ever touched. And I think giving people those like publicizing that's like, look, this is the data that actually gets used. These are the bytes that are actually moving. Will be helpful for people to assess whether or not a data set is valuable because they're like, oh wow, like everyone uses this one, it must be valuable. There's some peril in that though, because then it'll just reify the popular data sets. And there'll be data sets that they're new or they're undiscovered yet, and it doesn't look like they're being used much, but they're very valuable. So there's a balance you have to strike when figuring those things out.
all right, well, we're essentially at time here.
Okay.
Thanks for the time, Jed. That was a really interesting talk. I captured a couple pages of notes here, a bunch of links. We'll get the recording up and some notes on the wiki. And for next month, like I said, I don't have anybody nailed down just yet, but I'm gonna put out some more feelers here in the next day or two, and we'll let everybody know what next month looks like. So go ahead.
I'd recommend Chris Holmes if you haven't ever talked to him at Planet. He's
been here. It's been a while. I might have him
okay.
back.
Bring him back. And then
he presented on Stack maybe
yeah.
3 years ago, 2 years
Okay.
ago.
He'd be a good guy to talk to again.
Yeah, for sure.
And then Emilio asked a question about our search capabilities and source being very limited, which is true. The short answer is yes, we do want to add more features. So, but Emilio, if you want to email me, it's jed@radiant.earth or help, or the email address that's on here. So, all right.
Cool.
Thanks for
All right.
this.
Have a good afternoon, everybody.
Yeah. All right.
Thanks, Jed.
Bye.
Thanks,
Cool. Take care.
everyone.
Thank you.
I'm going to go ahead and end the call.